Lesson on factoring by grouping. So factoring by grouping, it's just a method that allows us to factor expressions further than if we just used common factoring or any of our other methods that we've learned to date. Let's take a look at the example. Which of these terms share a common factor? So here we've got a four-termed polynomial. This is pretty unique to factoring by grouping. Usually we only do it when we have four terms. So we've got 5x plus 9y plus 15y plus 3x. So, which terms are common? Well, 5x and 15y share a 5. 5x and 3x share an x. 9y and 15y share a 3y. And 3x, 15y, and 9y all share 3. What we can do is we can decide to group two of those terms that share common factors together. In this case, we may be more looking at grouping factors together that leave terms apart. So we should be looking at factoring 5x and 3x and 9y and 15y. If we were to factor those two terms in those two ways, we may be able to come up with a solution. Perhaps the best way to do this is by looking at an example. So, example 1, factor by grouping. For my solution, let's factor out a 7v from the first and third terms. And then we'll factor a 4 out of the second and fourth. Now, why did I choose 7v and 4? It was simply because of the fact that this was the most simple way for me to include factors from all four terms. Let's see what happens. When we take the 7v out of the first term, we've got 4v squared remaining. When we take the 7v out of the third term, we've got negative 3 remaining. Then when we factor a positive 4 out of the second term, we've got 4v squared remaining. And when we factor out a positive 4 from negative 12, we've got negative 3 remaining. I must show that this is what we're looking for. We're looking to get to have a binomial term that is common to both of our factors. If we've gone in the wrong order, we're going to have to go back and sort our issue out. But now that we have a 4v squared minus 3 term common to both, we can simply common factor it to the front, and we're fully factored. Let's take a look at another example. Factor by grouping. 4xy plus 6 minus x minus 24y. At first glance, it looks like I could factor out a 2 and a 2 from the first two. Then, oh no, I can't get an x out of there. Well, what about if I do a 4y and a 4y? Well, let's see. Let's factor a 4y out of the first and fourth terms, and we'll leave the second and third alone for now. When we do that, we'll have x minus 6 remaining. 4y comes out of the first term and out of the second term to leave x minus 6. Now we've got plus 6 minus x. It looks close, and this is a good thing, but it's not exactly the same. We want the sign of the 6 to be negative and the sign of the x to be positive. To change the signs, all we have to do is factor out a negative 1 from the third and fourth terms. That should get us to a common factor. Let's see what happens when we do that. Well, we've got 4y, x minus 6. That was simply from our first part. We took that negative 1 out, so now we have negative 6, because 6 divided by negative 1 is negative 6, and positive x. Now we can rearrange the second set of brackets. And you'll see that by factoring out a negative 1, we were able to accomplish our goal of having our x minus 6 and our x minus 6 similar, or common. So we've got x minus 6 common. All we do is factor the x minus 6 to the front, and we're left with 4y minus 1 as our solution. So factoring by grouping sometimes requires a little bit of creativity. Let's see what happens when an issue goes wrong. Suppose we were asked to factor the following question: 30uv plus 30u plus 36u squared plus 25v. There's a number of ways that we can solve this. And the first way that I saw was by taking a 30u from terms 1 and 2 and taking nothing from 3 and 4, since they share nothing in common. Well, here's what you get. You take out a 30u and you get v plus 1. Then you get 36u squared plus 25, and I'm sorry, that should say 25v. Well, it becomes a little bit difficult to change 36u squared plus 25v to v plus 1. So it looks like we'll have to start from scratch, because it looks like we didn't go the right way. Now, let's take a 6u from terms 1 and 3, and a 5 from terms 2 and 4. As we do that, we'll see that 6u comes out of the first term, leaving 5v. 6u comes out of the third term, leaving 6u. When we take a 5 from terms 2 and 4, 5 comes out of the first term, leaving 6u, and 5 comes out of the last term, leaving 5v. Well, all we have to do is rearrange the 5v and 6u, and we're off to a common factor. We have a 5v plus 6u common. So our final fully factored solution is 5v plus 6u and 6u plus 5. The key to factoring by grouping is if you run into a problem where you can't get a common term, go back and try pairing them differently as you factor. If at first you don't succeed, try again. Good luck with the homework. There's lots posted, and you should be able to achieve the final answers. The correct responses will be posted later on this evening.